So partitioning of a set. What is a partition? Partition of a set, yes, is the collection of a n disjoint sets, subsets you can say, that is P1, P2, and that is n disjoint sets up to the Pn you can say, that satisfy the following three conditions. So first condition is P1 does not contain the empty set. So the any elements that is Pi does not contains, okay, does not contains any empty set, okay, that is, so Pi should not be equal to the phi for all I where the I should be greater than 0 or less than n. Okay, so the union of second, this is the first condition. What is the second condition? Second condition is that the union of subsets must equal the entire original set. So the union of the subsets must equal to the entire original set. So we can say that the original set is S. So if I say that the P1, P2, P3 to the Pn is there, so I could say that the union of this, union of this, union of this will be the entire set. So we can say that this is going to be the entire set. Yes. Okay. So what will be the third condition? Third condition is that intersection of any two disjoint set is a empty. So any, if you take any subset of from this, that will be the empty disjoint of any subsets of this. All these are called as a subsets. All these are called as a subsets of a universal S set. Okay. So if I take a P of 0, so you can say P of A and an intersection of P, B, so we can say that always being a empty. This is the third condition for A is not equal to B, where we can say n is greater than A and B is greater than a 0. So this is called as a partition of a set. Now let us see the example and then we will proceed. So we have got a set S. Let us have a partitioning set. Now what is a partitioning set? In that partitioning set, you can see now the S is a partitioning set, that is A, comma B, comma C, comma D, comma E, comma F, comma G, comma H. These are the three, nearly the 7 elements are there. One possible partition is A. Any subset you can take, B, C, D. We will take it like this, and then C or E, F, G and H. Any subset you can take. So another partition is you can take any subset, that is A, comma C, C, comma D, comma F. Okay, and any subset A, comma F, comma G, comma H. Okay, so you can take any subset. So any subset from this set, that is called as a possible partitioning of that set. What is the Bell numbers? Bell numbers give the count of the, so we will say now we will go for the last topic, that is called as a Bell numbers. What is the Bell numbers? numbers, you can say. What is Bell numbers? Bell numbers, the count of the number of ways to partition a set. They are denoted by B of M. It is the Bell number. The number of ways you can do the partitioning. Where N is the cardinality of a set. Where N is the cardinality of a set. Cardinality of a set. Cardinality of a set. So example, if you take now, that is S is equal to, if you take, it's 1, 2, 3, and the number of elements which are being there is going to be the number of elements which are being there in the set of S is going to be the 3. You know it already. S is equal to S is going to be 3. So the alternate partitions are, you can say, I have a partition. First partition will be 5, 1, 2, 3. Second partition will be the 1, 2, 3. Third partition will be the 1, 2, and 1, 2, and 3, and 4 partition will be the 1, 3, and 2, and fifth partition will be 1, 2, and 3. Okay, so the hence B3 is equal to, so we can say the N is nothing but the cardinality. That's why it is a 3 elements are there. So that's why we write it B3 here. So B3 is equal to 5. So the 5 types of the, you can say, the number of ways we can write it the partitions. Okay, the count will be there. So in the next chapter we'll see the various number of the various types of the proposition logics, various types of the various notations also, and various types of the formulas, and various types of the conditions, various types of the rules, regulations, set theory with respect to the proposition logic and everything. Till then, goodbye. Thank you.